This is going to be M7, lesson 3. And the whole idea behind this lesson today is called proportions. Okay. We make proportions all the time. To give you an idea of how we use them, when a home is built, we have to use proportions to build a home. All of these bridges you see in the back of the classroom here, all of these bridges were designed on a computer first and then built, okay, using scale models and blueprints. They are all based on this idea of creating a proportion and understanding how that works. You'll do that next year as 8th graders, okay? So one of the things that you have to kind of think about when we're working with proportions is, what is it, okay? And I'll tell you right here now, proportions are literally special fractions. There's nothing really unique about them mathematically. Most everything that you have learned about fractions and rates and like unit rates, which was our previous lesson, 5-2, all of that is basically wrapped up in this idea, okay? So let's start with revisiting an idea. Okay, we're going to revisit an idea. And the idea here is, let's have the fraction 1/2. Okay, Jacob Parnan, thank you for making an appearance in this recording. Can you give me an equivalent fraction to 1/2? Something that it looks different than 1/2 but has the same value, okay, is literally 1/2. Can you give me an example of what that might be? 0.5 is a decimal. But I'm talking about a fraction that has the same value. Yeah. 4/8. That's a perfect example. Yeah. Okay. What else? Anyone else want to? Yeah. Yeah, 6/12. Okay. What other ones kind of? Yeah, Mackenzie. Yeah, 3/6. Yeah, 12/24. 50 100ths. Okay, I'm going to stop there. Okay, so all of these fractions, if you were to divide them on a calculator, 1 divided by 2, 4 divided by 8, 6 divided by 12, Katie Fady grabs a calculator, does 3 divided by 6, Miss Lixon does 12 divided by 24, you know, LW over here with the cool headband does 50 divided by 100, you all are going to end up with the same value, 0.5. They all equal that. That's what they equal. They all have, and for lack of a better kind of term or one word, they all have the same value. Okay? That's why we call them equivalent. Is there anyone that is right off the bat confused by this idea? Because I don't want to move on until I feel like we're all on the same page. Okay, Parker. No, what I'm saying is, right now we're just looking at something that we looked at in chapter 1. What I'm now going to do is I'm going to transition and use the same idea for proportions. Okay? Is that? Huh? You think of? That's great, my friend. Okay. So, before we get on, what page in the text is this? Okay, let's put that up here at the top so that we can reference it if need be. All right, I think you got the idea of this equivalent fraction thing down. Let's move on. Okay, a proportion, like a rate, is a comparison. Okay, so I'm going to go ahead and start with that idea right there. Proportions are comparisons. And let me zoom in here a little bit. Proportions are comparisons of, I will say, objects, subjects, things, heck, we'll just say stuff. They're comparisons of stuff that have the same units. I'll give you an example of what I mean by that, because I feel like that statement all by itself might be slightly confusing. So, for instance, let's say I wanted to compare two people's height. Okay. Now, two people's height. Let's just start with that example right there. Ladies and gentlemen, I am 5'11". This is how you would write this. This means 5 feet, 11 inches. Okay? My mother was 5'2". She was 5 feet 2 inches. She was relatively short. Okay? So again, feet and inches. How many total inches is 5 feet 11? How might I find that? How many total inches is that? Let's just kind of start with this. This is kind of a review of conversions a little bit. How would I go about finding that? Isabella? Right, how many inches are in 5 feet? Well, there are how many inches in 1 foot? 12, and I have 5 of those. So 5 times 12 is, yeah, ooh, very good. 60 plus 11. Yeah. So I am 71 inches. I wish I was 72, because that would make me 6 foot. But I've never made it. Okay? I fluctuated a solid quarter of an inch for like the last 10 years. You know? Sometimes, if I breathe in real tight, I might grow like a quarter of an inch. That's about it. And sometimes if I slouch, I'm a little shorter, but nonetheless. So I'm 71 inches. My mother was, if 5 feet is 60 inches, how many total inches was she? 62 inches. Okay. So here's what I want to do. I want to create a ratio or a proportion comparing. I want to create something to compare these. Okay. So in theory, if I create a ratio, if I create a ratio of this, I could say that I am 71 inches to my mother 62 inches. That really is just 71 over 62. Okay. So this here is a ratio. We've talked about this. Ratio, rates, proportions are comparisons of stuff that have the same units. And let me back up here a little bit. Not proportions. Cross that out and put rates, or ratios. I know, I'm sorry. Well, let's just go ahead and back up. I want to make sure that ratios are comparisons of stuff that have the same units. This is a ratio. Okay? This is a ratio. It's one fraction. So ratios are one fraction. It's a comparison of two things. Now, I want to know if the ratio of my mother's height and my height, okay, so I was doing a comparison, is equal to 71 over 62. I want to know if that is equal to 5/4. Because when I compare two fractions, so notice here's a ratio, or I should say two ratios. Here's a ratio, and here's a ratio. When I compare two ratios, this is called a proportion. Now, ladies and gentlemen, this is really not that difficult. So let me show you kind of how you could figure this out. On your calculators right now, take 71 and divide it by 62. Go ahead and do that for me right now. Yeah, 71 divided by 62. I'm not going to jump to anyone's answers yet. I want you all to kind of try this. You take 71, you divide it by 62. Okay, it does. It's going to give me a decimal. It's going to give me 1 point something. Okay, what is it going to be? 1 point what, Hannah? 1.45. Let's go one more place. 1. Okay. Now the question is, does that equal 5/4? So right now on your calculators, take 5 and divide it by 4. And what's it equal? 1.25. So in looking at this right here, does 71 over 62 equal 5/4? Does 1.45 equal 1.25? Are those exactly the same thing? 1.45, that's like saying 1 equals 2. Does 1 equal 2? No, 1 equals 1. 2 equals 2. 3 equals 3. 1.451 does not equal 1.25. So therefore, this does not equal this. This is what we call a false proportion. It means we've compared two ratios, two fractions, but they are not equal. So they, in theory, do not form a true proportion. Well, it's not bad. It's just not true. We use this in the sense of if we are trying to compare percentages. Oftentimes we use this in percentages, and you'll see this more as we move on throughout the year. All right, now let me give you one that actually does work, okay? This one doesn't, but let me give you one that does. In your homework, you're going to see something along the lines, and I can go back if need be in just a moment. You're going to see something like this. You're going to have a problem that says, do the following proportions hold true? Yep, meaning are they true, and if not, okay, tell me why. So I'll give you two examples. Okay? 4/8 equals 6/12. Okay? And I'll give you another example of 3/2 equals 15/10. Now, at first glance, 4 over 8 and 6 over 12, they don't look exactly the same. They don't look anything alike. They're totally different numbers. But you have to remember that fractions can be simplified to have the same value. And if you can simplify both sides so that they are equal, we would say that the proportion is true, or that it is a proportion. So 4 over 8, okay, simplifies to what fraction? Yeah, Jacob, pardon? Yeah, it simplifies to 1/2. And 6 over 12, what's that simplify to? Yeah, Mr. Parner? 1/2. And would you say that 1/2 equals 1/2?
No.
Yeah, 1/2 is equal to 1/2. So we would say that this is a proportion. That 4 over 8 equals 6 over 12. Because when simplified, both sides equal each other. Okay? Now, looking at this next example, at first glance, this is, well, first of all, we have two improper fractions, and that's fine. You're allowed to have improper fractions when you're working with ratios and proportions. So, hurrah, okay? No mixed numbers. But the question is, okay, this doesn't automatically lend itself to looking like it might be the same. So I'm going to approach this a little differently. I'm going to say, what could I times by 3 to get 15? Yeah, Gabby? 5. I could times it by 5. Okay? And if I times 5 by 3, I do get 15. Okay? Now, whatever I do to the top, I must do to the... Yeah, I got to do it to the bottom too. That's kind of the golden rule of mathematics. So I have to, in order to test this, do the same thing to top and bottom. Katie Fady, I am positive that you know the answer to this question, so I'm gonna toss this your way. 2 times 5 is... Oh, I just know my students. So 2 times 5 is 10. So 3 times 5 equals 15. 2 times 5 equals 10. If I can multiply top and bottom by a number and get the other side, then that proportion is true. That proportion is true. And so, again, this is an okay proportion. Now, oh, Mackenzie Berg, you are totally right. I could do that. I could take 15 and divide it by... It does. I could take 15 divided by 10 and 3 divided by 2, and they both would equal 1.5. Yep. Let me go with that. Savannah, take 3 divided by 2. It is. And take 15 and divide it by 10. If both sides equal each other, then your proportion holds true. There's lots of ways to check this. So Mackenzie, you find that's easier, right? Yeah. But see, now Jacob Parnan, I think that he just saw this here, and he was able to say, hey, that's 1/2, that's 1/2, and that's good. So sometimes we even just see it. Okay, and that's fine too. Well, see, now we're in tricky waters. You definitely should show work. If for no other reason than on a homework quiz, if I expect it, you'll lose points if you don't have it. So you should always write at least the original problem, just in the case that you are working with a homework problem. So I want to look at one more example before I answer any questions, Ms. Rainey. And I am going to look at on page 240. Okay, I'm going to do this. This is one of the questions from your homework. Page 240, and I'm going to do number 14. Okay, Isabella? Yeah. All right, Sniffles. Could you please read me number 14? Okay, first of all, read the directions. Okay, read the directions, and second of all, then read me the two ratios that we're working with. Okay, so we're asking ourselves, can the ratios form a proportion? So Savannah, we have to have, the word here, ratios, is plural. We have to have two ratios. So Isabel, what ratios are we working with? 15 over 45, and there's a comma there. What's the next one? 3 over 15. All right. Right. What it means is they're just giving you two ratios. They're listing them. Now, Jacob Parnan, here's what we do. Thank you. Here's what we do, Mr. Parnan. We are going to simplify both of them. Okay, I'm going to simplify both of them. So 3/15 can simplify down to what? I know. Yeah. It can be 4. No. Wow. 1/5. Yes, it is. Nice job. It's 1/5. That is the simplest that one can go. Now, what about 15 over 45? That one simplifies down to, what is it? Hold on. I think she's getting close to this. Millie, 15 plus 15 is 30, plus 15 is 45. So how many times does 15 go into 45? 3. Yeah, great job. So it would be 1 over, so 1/3. Now, if these ratios could form a proportion, they would have to be equal. So Katie Fady, does 1/3 equal 1/5? No. So because 1/3 cannot equal 1/5, the answer to this question, can the ratios form a proportion? The answer is no, they cannot. Do we want to do one more from the homework? All right, let's do one more from the homework. All right, let's look at number 22. Number 22. Yeah. Noah Miller, could you please list the two ratios for number 22? All right, Noah, please. All right, 6/14 and 3/7. Okay. Again, what we do when we are trying to decide whether or not they can form a proportion, we simplify both ratios. So 6/14 simplifies down to what? Okay, I can divide both of well, let me ask this question first. Okay, Noah Hogel, what can go into both 6 and 14? What number? They're both even. So what number can go into both of those? 2 can. And how many times, Isabella Walker, does 2 go into 6? 3. Right. It goes in 3 times. So we would say this is 3. And how many times, Gabby, does 2 go into 14? 7. Now, this one, 6/14, simplifies to 3/7. Well, I see that that other side is also 3/7. I don't really need to simplify it if I can figure out they equal each other. So if does 3/7 equal 3/7? It does. So do these two ratios form a proportion? Yes, they do.